Hello students, welcome to Future Doctor NEET Academy. Today I am going to solve some basic principles and technique. This is one of the lessons in organic chemistry 11th standard portion. Okay, so now let us see the first question. Listen, the number of structural isomers possible from the following, from the molecular formula C3H9N. Okay, so by using this molecular formula, we have to frame how many isomers are possible. Okay, so this is amines. No, N only is there, so it's called amine. Amines means classification of amine, primary amine, secondary amine, tertiary amine. So each and every one we have some formulas are there. So here for primary amine, you know that. So for primary amine, 10, no. So for primary amine, okay. So what's the formula? You know that R NH2. This is a formula. Understood, right? This is a formula. So here 3 carbon, no. So what are the possibilities? So we can write CH3. Understood? CH3, CH2. Then CH2, NH2. Okay, this one possibility. One amino, propane. Then we have 2 amino is also there, no? So CH3, CH. You know that. Understood? So here CH3. Understood? Okay. So this is for primary amine. So these are the possibilities. Okay. Then for secondary amine. Okay. So you know that what's the formula? R. Just replace one hydrogen by one more R. So this is a formula for secondary amine. So R NH, R dash. Okay. So how can you write this by using this molecular formula? Means here two radicals are there. No, in one radical I put CH3 CH2. Understood? In other side I put what? CH3. So this is one possible. Okay, understood? So that's all. So this is only one possible isomers for secondary amine. So likewise tertiary amines, 30, simple. For 30 amines, what's the formula? R3N. Okay. So R3N means here for 3 carbon, no, so we can put 3 methyl group. Understand? So CH3 thrice. Okay. So these are the possibilities. Okay. So totally for primary amine two isomers here. For secondary here one. Totally what? So 4 possibilities. Okay. So there are a number of structural isomers by using this molecular formula. We can write what? 1, 2, 3, 4. So understood. So these are the possible answer. Option A is the correct one. Understood? Right. Simple one. Second one, which of the following compounds contain all the carbon atom in the same hybridization state? Okay, same hybridization state means here all will be sp, or all will be sp2, or all will be sp3. Okay, so here CH3 means that sp3 will be there. Understood? Here sp, this also sp, here also sp3. So 2 different oxygen. This also leave it. Here what? sp2. Okay, yeah, this is sp2, but this is sp. Understood? Here this is sp2. This also this also what? sp2. Okay, so sp2. Okay, right. Now we have to check each and every one. Now see that I told you if you have sp3, what is sp3 hybridization? We have what? So 4 sigma bond, isn't it? 4 sigma bond. For sp2 hybridization, we have 3 sigma bond. For sp hybridization, we have what? 2 sigma bond around the carbon atom. Understood? So here they are asking which compounds having all the carbons having same hybridization state. That's a question. Understood? Okay. So here if you take this one, this side sigma bond. Understood? Here also sigma bond. Okay. So this also sp 2 sigma bond. No. Here also 2 sigma bond. Here also 2 sigma. So all this carbon having what? sp hybridization. So this is the correct one. Understood? Are you following? If you expand the structure, suppose this one I expand. This is C H. Understood? Here triple bond. Understood? C, it goes on. So again C, again C, here C, triple bond. Understood? Okay. Then CH, it goes on like this, no? Okay. So here, single bond means simply you can put sigma bond. Okay. Here also, if you have triple bond means first will be sigma bond, next will be what? Remaining will be considered as what? Pi bond. So here, sigma bond, here. Okay, simple. 1, 2, 3, 4 carbon only is there, no? Okay, right. Again C triple bond, again CH. Understood? Okay, now you know that as usual, here sigma bond. First bond will be sigma bond, remaining will be what? All will be pi bond only. This is also sigma bond. Okay. So each and every carbon around this we have only 2 sigma bond, 2 sigma bond, here 2 sigma bond, 2 sigma bond. So all having the same. So 2 sigma bond means we can say what? All this carbon in this first compound is sp carbon. Understood? So this answer. Understood? Next one. Third one. Name the type of intermediate formed in the first step of the following addition reaction. So intermediate means, suppose electrophile group is there, here electron rich is there. So when we add means, when you do the protonation process, so which is stable carbocation, we have to find out. Sometimes if H goes here, plus goes here, so we are getting primary carbocation. Suppose H goes this side, plus goes here, so we get secondary carbocation. So mostly the secondary carbocation is more stable when compared to the primary carbocation. So the possible product is what? Suppose when you do protonation, so this will be possibilities. CH3, okay, CH, understood? Here's single bond, CH3, understood? So this will be possibilities. Okay, so this carbocation is called secondary carbocation. This will be the intermediate in the first step. Okay, right. So here secondary carbocation. Secondary carbocation means this answer. Secondary carbocation is the intermediate. Understood? Are you following? Okay. Next one. Which of the following compounds will exhibit cis-trans isomerism? Cis-trans isomerism here. You have to work out all the compounds. Okay. So I'm going to work out only the first one. Butene to 2-butene. No. 2-butene means one. 2-butene means double bond in between 2 and 3. The remaining place you can fill by hydrogen CH3. Here also, here what? CH will come. Here also what? CH. Here what? CH3. Understood? This is called 2-butene. Okay. So by using 2-butene only we can able to frame cis isomer as well as trans isomer. See here, that cis means what? Same side, same groups are there. That's called what? Cis isomer. Understood? Same side, same groups are there. That's what's called cis isomer. This is called cis isomer. Trans isomer means same group in opposite side. Understood? Are you following? Same group in opposite. Same group means, suppose if I take CH3, but CH3 will be in opposite side. Same group in opposite side is called trans isomer. Understood? So here this is possible only in the first compound. So that's why 2-butene is the correct one. Understood? Next one. On IPOC name of the following compounds. Okay, simple one. Suppose I given around or on benzene, we have CHO is there, NO2 is there, OCH3 is there. So you give importance to carbon-oriented group. So here CHO is the carbon-oriented groups. Then only this is the basic compound. Okay, it's a parent. We consider this a parent compound. Understood? This is considered as a parent compound. So parent compound is what? Benzaldehyde. Understood? After that we can do see the position. Now see the NO2 in second position. No, then methoxy group in fourth position. Okay, so NO2 in second position, methoxy group in fourth position. Understood? So simply you can say 4-methoxy 2-nitro benzaldehyde. Okay, so among the 3 groups, CHO is the carbon-oriented group. Then only this is considered as a parent compound. Understood? So option A is the correct one. Understood? Next one, the correct order of decreasing acid strength of trifluoroacetic acid, acetic acid, and formic acid. Okay, so you know that acid strength depends upon more electron withdrawing group. So when compared to if you take halogens, who is having more tendency to withdraw electron means what? Fluorine, then chlorine, then bromine, then least note is what? Iodine. Okay, if any compounds having fluorine, it has more electron withdrawing tendency. So which compounds having fluorine? This is trifluoroacetic acid. So B is having, so they are saying correct order of decreasing. So decreasing means first we should write the highest one. So trifluoroacetic acid, B is having more acid strength. Understood? Right. Next one. Next one is what? Trichloro. So BA. Understood? Next one is A, common A, trichloroacetic acid. Next one is, so this having more tendency to withdraw electrons. No. Okay. Likewise, acetic acid, acetic acid, then formic acid, formula for acetic acid, is the formula, CH3COOH. Formic acid, what's the formula? COOH is the formula. Okay, so here this is, I told you, if electron withdrawing group increases, okay, acid strength is also what? Acid strength also increases, isn't it? If electron donating group increases, electron donating group means, methyl, ethyl, this is all electron donating group. If electron donating group increases, acid strength decreases. Okay, acid strength, okay, just remember, okay, acid strength decreases. This all you must know. Okay. So here methyl is what? Electron donating group. But in this case, here no electron donating group is there. So least one is what? Here electron, if it donates electron, it makes the OH bond very strong. So it cannot be able to lose H plus ions very easily. So this is the least one. The least is what? C is the least. Okay, C is the least. Okay. Then next one is what? D. Before that we have D. Okay, this order. Okay, are you following? Okay. So B, A, D, C. So answer A is the correct one. Understood? Okay. So this all you must know. Okay, this is electron withdrawing tendency. This is what electron donating tendency mean all alkyl groups having electron donating tendency. Okay, right. Next one. How many chain isomers? Seventh one. How many chain isomers could be obtained from the alkane C6H14? Okay. Only they're asking what? Only chain isomers. Chain isomers. Okay. Chain isomers, here how many carbon here? 6 carbon. No. So first you write. This is one possibility, Correct or not? All the carbon straight line. Another one is, what's the next one? What's the possibilities? 5 in straight line. Correct or not? 1 in branch. Okay. Then there's 1 in branch. This is if you come from right to left, 2 methyl. No. If you come from right to left, 2 methyl. Okay. So 5 in straight line, 1 in branch. Or next one is 5 in straight line. That if first case, second carbon having branch. No. Now I'm going to put third carbon having a branch. Understood? Right. That's all. This is only possible on 5 carbon straight line. Next one is 4 in straight line. 4 in straight line. Okay. 2 in branch. Okay. 2 in branch. The 2 in same carbon. Okay. 2 in same carbon. So this is one possibilities. Then again 4 in straight line. The 2 in 2 different carbon. 2 in 2 different carbon. Understood? You following? So these are the possibilities. Understood? Is there any possibilities? All carbon straight line. In second cases, 5 in straight line, 1 in branch. That 1 in 2 different carbon. Here 4 in straight line, 2 in branch. The 2 in same carbon. Another one is the 2 in different carbon. So these are the possibilities. So what are the how many isomers are means? 1, 2, 3, 4, 5. Okay. So 5 is possibilities. Okay. 5 chain isomers are possible. Understood? So answer is what? B is the correct one. Understood? So I didn't fill up the hydrogen, but you know that. Okay. 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 These are the 7 questions in this chapter. Okay. I hope you understood everything. Okay. The next class, I'll give the other 7 questions. Okay. In different chapters. Okay. Thank you, students.